Module 1, Measurement, Units, and the Scientific Method. Introduction. As we begin to study the details of chemistry, I want to emphasize how much this branch of science plays a part in our everyday lives. From medicines for when we're sick, to the materials in our homes, cars, and even clothing, to soaps, household cleaners, and foods, chemistry plays an important role in the production of these products. Understanding what's going on chemically within our oceans and rivers, our earth, and within the weather helps us to protect and maintain the world around us. In this module, we will begin covering the basics of understanding this amazing branch of science. Let's begin by defining what chemistry is. Chemistry is the study of matter. Well, what is matter? Matter is anything that has mass and takes up space. That means that nearly everything surrounding you right now is matter. The chair you are sitting on, the pencil you're writing with, the glass of water next to you, both the glass and the water, are made of matter. They have mass and they take up space. Even the air you are breathing is made of matter, though you cannot see it. Let's take a closer look at this idea in the following two experiments. Module 1, Measurement, Units, and the Scientific Method. Experiment 1-1. In this lab, we're going to learn about whether or not air has mass. Now, we don't normally think of air as being made of stuff, so this is a good way to identify whether air has mass or not. So we're going to begin with a meter stick, and I have a couple of pieces of string that I'm going to tie on both ends, and I'm actually going to use some cellophane tape to tape it on one side like this, and then I've got another piece of string the same length I'm going to tape onto the other side. And you want to make sure it's nice and secure because you don't want the string to come off, because you're going to be doing some things with the string. So I'm just going to make it nice and secure on both sides. And then I've got two balloons with no air in them. I'm going to take these balloons and loosely tie them to the other end of each of the strings. And we're tying them loosely because we're going to do something with one of the balloons. I've got this one done right here, and this one next. Okay. Now, if you're doing this lab, you need to find a place where you can balance this piece of ruler. And so I have this great little doohickey right here next to me. If you are at home, a good place to do it would be the shower bar in a shower, or the back of a chair, or someplace, or maybe even having a human helper who can hold their hand out like this. So I'm going to do this right here over this rod. And we want to place it so that our meter stick balances. Takes a little bit of patience. Okay, once you get it balanced, what this is saying is the total mass on each end of the meter stick is equal. Total mass on this side equals the total mass on this side. Obviously, if the mass was heavier on one side, it would tilt towards that side. So what we're going to do now is I'm going to hold this bar in position using a clamp so it doesn't move. And now I'm going to take this balloon and take it off of the string, blow it up, which means I'll be filling it with air, and tie it back on. Okay, so you can see I have filled this balloon with air. Now, this side of the bar, when I tie it back on, is going to have the mass of the string, the mass of the balloon, and the mass of air. This side of the bar is going to have the mass of the string and the mass of the balloon only. Let's see what happens when I remove that clamp after I tie this balloon back on. Okay. And you can see it's actually tipping towards the side with the air and the balloon. I'm going to move it a little bit further forward So you can see it hanging off of the table. And there it goes. It's tipping towards the left. What that means is the mass on this side, the mass of the string, the mass of the balloon, plus the mass of the air, is greater than the mass of the string and the balloon. Therefore, we can conclude that air has mass. Module 1, Measurement, Units, and the Scientific Method. Experiment 1-2. When we talk about air, there's a lot of really fun things we can do to examine it and observe it. And one of the things we want to find out about air is whether it takes up space or not. So I have a large tub of water in front of me, and I have a beaker which is filled with air, right? There you go. I've just filled it up with air. I'm going to take a paper towel and crumple the paper towel up just into a wad and stuff it into my beaker so that it doesn't come back out again. Okay, so it's kind of wedged up in the beaker. And then I'm going to take my beaker and turn it upside down and put it into the water. Let's see what happens. Hold it under the water. It's completely submerged. Let it sit there for a few seconds. All right, let me pull it back out. And let me reach under and notice my paper towel is still dry. Why did no water move up into the glass? Well, because it was filled with air. The beaker was full of something, so water couldn't get in there. There was no place for the air to go. It was stuck in the beaker, so water could not move into the beaker because air was already there. So now I'm going to submerge it one more time, and I'm going to tip the beaker a little bit to allow the air to escape. And of course, you'll see what happens. You probably have an idea what happens. So here it goes underwater again. And now I'm going to tip it. Can you see the air escaping? Now that the air is escaping, what's the water doing? The water is moving in to my beaker. And of course, my paper towel got wet. So the conclusion from this lab is air indeed does take up space because air is stuff. Air is made of stuff, and we have to get our brain around that it's not nothing. It is made of material. We just can't see it, and so we don't think it exists. But air is made of material, and therefore air takes up space. The last two labs showed how air has mass and takes up space, so therefore air is made of matter. But there is something else surrounding us that does not have mass and doesn't take up any space. It is light. Scientists have been studying light and its properties for centuries, and so far have not found that light is made of matter. It is believed to be made up of energy. Why am I using vague terms about this? Well, we simply do not completely understand exactly how light works. There are several theories that seem to be supported by experimental data, but there are still some things that are not completely understood. For the purpose of this course, we will go with the current data that say that light is not made of matter, but is made of pure energy. But everything else around you is indeed made of matter. So if chemistry is the study of matter, then we can say that chemistry is the study of practically everything around us. That means we have a lot of work to do in this course. Well, don't worry, it will be fun and fascinating, and you'll learn that all matter follows some fundamental laws that can help us to better understand the nature of matter. Let's begin by looking at the best way to study matter, by measuring it. We need to be able to identify how big something is along with its mass. So for the rest of this module, we'll be looking at how to measure things and the meaning of those measurements.